Today, I'm going to be continuing in my series of understanding and kind of explaining how Git works. Right now, I'm going to show you how to fork and clone the example repo that we're going over today. If you want to skip this and just kind of watch what I'm doing, you can go ahead and do that. I'm going to provide a link in the description, of course. So forking allows you to take someone else's repo and to basically copy it over into your account. So what you'll see right here is like this path is the Shadi JR. What I want to have is my account, which is Madi ACS. How I do that is I go here to fork, which is the upper right corner here. It says fork. You click that. If you have multiple accounts and multiple orgs, then you have to specify which one. You might not have to do that if you just have one account and that's all you have going. Here, I'm just going to select my user account and it's going to fork it. It's basically just copy all the files and the Git history, the commit history, and now it's mine. You'll see that has my account here and it says it was forked from this other repo. So now this repo is mine. I have permission to change the files and do whatever I want to this repo. It will not affect the original though. What I want to do is to take this remote repository and clone it down to my local computer so I can start working on it. And I would do that by going here to the code, and it says you don't have a public SSH. Okay, so I haven't set that up for this account. What I'll do is I'll use the HTTPS. Here's the thing I will mention: you do not download it as a zip. The whole point of this exercise is that we're going to be running through the commit history together. If you download it as a zip file, that there is no commit history. You're just downloading the files. So do not use download computer. So here I'm copying this. This right now is git bash. I'm gonna go to my home, go into my documents, and I think I'm just gonna kind of leave it in my documents. So you can put it wherever you want, git clone, and then I paste the link that I had. So I paste that. Now what's gonna happen is it's going to download everything from the remote, and it will name the folder dad jokes because that's the name that the repo is. If you wanted to change it to something else, you can say, you know, my dad jokes 2 or something. You could call it whatever you want as another argument there. LSAL, I can see my dad jokes 2. Here I'm going to CD into my dad jokes 2. First, let's actually look at our commit history. We can do that by listing it out using git log. I like using the one-liner, so I do double dash and say one line. I have a bunch of files here. I made a website that shows dad jokes, hence the name. So you don't need to worry about, you know, what the code means or like how to use React. What matters is the changes being made, how we're tracking them, how Git works. That's what I'm trying to showcase here. So we have a bunch of commits here. We see them in order from the first to the last. This commit history, I'm going to make it visual, and here's what it's going to look like. You can see I've also included the files as well as like the changes. So there are a number of ways of like kind of seeing what your commit looks like. I think the most visual way that is intuitive for me is to actually go to the remote repository. So I'm going to go there here, and you can look at the commits from that perspective. So here I'm going to click on the commits. There are 13 commits apparently. If you click on the link here, you can view the details. You can actually see, oh, these are the files. There are 4 files that change, and you can actually see the changes. So this is the state we are currently in. I'm also noting that there are these pointers here, and I'm going to zoom in here, of head and main. Basically everything is just an object reference. Okay, one thing pointing to another thing. That's what Git is kind of doing and managing under the hood really well. So what we have here is head, which is basically referring to what am I currently looking at? What am I currently viewing? So head is pointing to the main branch, and the main branch is pointing to this commit. I'm gonna give you a scenario here of like, hey, I've committed this thing locally. I've done a local commit. This last commit that I just made, you know what? Actually, I'm not too sure about it. I kind of want to undo my last commit. Essentially, what I'm trying to do is put the pointer of the head to the last commit. What this is, what this state represents is the state of my local computer just before I committed the last commit. The working directory had my changes, the staging area had my changes, but the last commit is out of date. How do I get there? If I do git status, it says, hey, you have nothing to commit, a clean working tree. This is what a clean working tree looks like. It means A, B, and C. All these buckets are the same. That's what a clean working tree looks like. How do I undo this commit and get it to the point where I say, okay, head, point here now? The head has a reference. You see this little pointer here. Each commit has a pointer to its parent. The way we can represent that is to do a little squiggly line. I think it's called a tilde, and then you put like a 1. because you're basically saying go back 1. You could also go back 2 or 3, or however long you want. Right now we're just going to go back 1. So we do git reset, you do double dash, and we say soft. Okay, we specify which SHA or which commit we want to do. We could just say head squiggly line and a 1, meaning go to the parent of the current head. Once I click enter, we have now basically told Git, hey, point this here now. Our working directory and our staging area has the changes that we wanted, but the current commit we're looking at is the previous state of that it was in before I made the last commit. How do I check that? I could do a git status. So that's what's called a soft reset. You're just changing the head pointer to somewhere else. You're leaving the staging area and the working directory as they are. This is a nice way of like undoing your last commit if that's what you really want to do. I would say that this is important when you're working locally, when no one else knows about your commit, because in that case, you can kind of like mess around with your commit history. Once you have committed your history to the remote branch and other people have access to that, then I'd be a little bit more wary, because you would preferably want to do something that's like an additive change. You could always add, but what if instead of my staging area to look like this, I actually want it to look like my current commit? How do I do that? What I'm going to do is do what's called a mixed reset. Okay, so if I do git reset double dash mixed, and you mention the head, well, right now we're actually on the head, we're actually like in the spot we want. Git reset mixed head, I'm going to run that. You'll see it said, hey, we unstaged changes. I'll do a quick git status here. What this is saying is we have a difference between the current working directory and the staging area. There's the difference, right? And so you see that this README is modified, and we have these 2 new files that are untracked, meaning that they don't exist in the staging area or in the current commit. These are untracked files at this point. So this is the current state of things, where the staging area now resembles the current commit, and the working directory is the thing that has all the new changes going on with it. Now, I wouldn't be doing my job if I didn't show you the last way you can use git reset, and that's to do a hard reset. And it sounds very much like what you think it is. It's just going to change everything to whatever the commit you're pointing to is. Let's do an example here where I go back to this one here. I'm going to say git reset. I'm going to do double dash. I'm going to say hard. And this one is actually the parent of the current head. Say head, and I'll put a little tilde 1. Okay, so I'm actually going to change this head over here, essentially. I'm going to run that. Okay, so we're now at this point where we're now pointing to the head here, and we're potentially going to copy everything over to the staging area and the working directory. I do want to show you one interesting thing about what we're doing here, and I'm going to do a git status and show you what's going on. So this is weird, right? Because it says we have untracked files. You would think that what ended up happening is we kind of copied everything from the current commit, which is here, to the staging area and then to the working directory. And that is what's happening. The issue, though, is when we did our last mixed reset, we had untracked files. And you have to keep in mind what that means. An untracked file means that Git has no knowledge of it. It is just a file in the repo that Git is essentially ignoring and not touching. And that is why it is still here. What we can do there is do what's called git clean, I think it is. I think IN is what it's called. Yeah, this is it. It's clean FD. Okay, I see. So clean FD. Okay, that's what that is. Okay, so I knew I had it. So git clean FD. So basically, you're saying, hey, please delete these untracked files. Okay, so what is the current state we're in when I do git status? Okay, it's going to say, hey, we have a clean working tree, meaning that everything is in sync, working directory, staging area, and this particular commit. This is a really nice way of kind of getting rid of all your dirty mistakes that you just like are embarrassed about, or you just like made a mistake and you just I definitely don't want those changes I made. You can always go back, and that's the beautiful thing about Git. It's version control. You can always go back to a previous version and just wipe the slate clean, or leave it as dirty as you want, mixed. So this is a really nice, versatile way of kind of cleaning up your situation depending on what you want to do. Now, I know there are people out there wondering, well, hold up. We have essentially lost the pointer to this last commit. There's nothing pointing to it. It is gone. It's been garbage collected. Now, you are somewhat correct about that, because when Git does some like routine cleanup, it will look for any references that don't have anything connected to it, and it will do garbage collection on those. So you do need to be mindful that you don't want to like leave this state for too long if you do want that commit back. So there actually is a reference to this. It exists in the ref log. So let's check that out. Git ref log. Whenever you make a commit, whenever you reset, whenever you do anything and you change references, it keeps a log of that, hence the name ref log. So I do still have a reference to this commit. So 2726, that exists right here. And you can kind of make sense of it, right? Because this is all the stuff that we were kind of doing. I've been messing around a little bit, so your history might be a little different than mine because I've been like editing things while I'm doing my video recording. So we have a reference to it. I can copy this, so I'm going to copy that, and I can always go back to it. So I can always do git reset, and I can do a hard reset here. I can do whatever I want, right? Hard reset. And instead of using the head as a reference, I could just be explicit and just paste my commit SHA, and it'll reset that. And it's doing a hard reset. So here we are. So now what happened? Let's do git status. Okay, nothing's there. I'm gonna update my visual here, because what we essentially just did is we said, okay, our head, we're gonna point it now all the way up to this last commit that we've had, and we did a hard reset. So everything in the staging area, boop, you're done. Everything in directory, you're also done. And we just copied it over. Okay, this is the current state we're in. You have a reference to everything. This is version control, folks. This is the power of Git, okay? Now, I did mention something before about using additive changes and how that's preferable. And the reason why is because when you're working by yourself, you can kind of do whatever you want. It doesn't really matter. But if you're working collaboratively and you have a shared repository, you don't want to mess up the shared history. How can you maybe undo a commit that you've pushed to the remote in a collaborative way that doesn't mess up everyone else, okay? Git has the inner workings to understand how to make those changes to make this state go back to this state, but it's going to do it in an additive way. It does that by just making a new commit, okay? Let's take the last two commits here, and we want to say those two commits that we pushed remotely, we actually want to undo those. So we want to revert those, and we want to bring things kind of back to the state that we were in here with the EEAE commit, okay? How do we do that? How do we do like multiple reverts? So we're going to do git revert. What we're going to do here is the range between this one and this one. Git revert, and then you can say the head, and this is going to be like how far back you want to go. Squiggly line 1. The first value here is actually not inclusive. It's called exclusive. So you want to do head 2, which is referring to this commit. And they put two little dots here, which is like, I guess, like the representation of a range. And you can say head. You can actually omit the head because it's understood that you're just saying go back that far and revert everything up to the current point, which is the head. Okay, so my window popped up here. It's basically saying, what do you want your commit message to be? I'm going to zoom in a little bit. So I think this is fine. So I'm just going to close it out. And then it pops up again because it's going to ask me for the other commit that's within the range. Okay, so let's check something out now here. I'm going to say git log, and I'll do one line. We now have two new commits that were added. We've created two new commits that revert backwards, essentially. And sure enough, our staging area and our working directory are also up to date. So let me clear this out. Okay, and I can verify that. If I can do, git status here. Sure enough, everything is fine. We're in a clean working tree. So revert has now updated everything, and now we're in the same state we were in two commits before. We could push this to the remote, and the changes could be pulled in by our collaborators, and everything's fine. No one's going to have a problem with this because the commit history, everything else prior to this has been preserved, right? All that has stayed the same. All right, folks, that is it for today. But if this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I will see you next time.